Hello geometers, and in this video I am going to explain another problem that many people seem to get wrong, or they have a hard time finding the right answer. So let's look at what the problem description says. Find the area of a right triangle with a given leg L and a hypotenuse H. Round decimal answers to the nearest tenth. Okay. I'm going to do number 11 here. So what we want here again is the area. Okay, so this is a very common area across all mathematical classes, and it's just from people being maybe a little careless or rushing through, or maybe not reading the directions entirely. But so let's start out and just attack this problem here. And I always like to draw a picture, and we know that it's a right triangle, so it's 90 degrees, and the hypotenuse H is 25, and one of the legs is 17. Now, remember that the area of a triangle is the base times the height. Okay, I'm going to write out the word height here, divided by 2. So base times height divided by 2. Okay, I don't want to get confused with this H, which stands for hypotenuse. So in this case, we could use either of these legs as our base and either of them as our height. So I'm going to use 17 as my base, and we'll figure out what the height is later. So this is going to be 17 times the height. I'm going to call the height x. X over 2, and I'll even go a step further. This is 8.5x. So our goal here is just to figure out what x is equal to and then substitute it into our expression here. So using the Pythagorean theorem, x squared plus 17 squared is equal to 25 squared. X squared is equal to 25 squared minus 17 squared. So this tells me that x squared is equal to 336. And I'm going to continue up here. That means x is equal to the square root of 336. Now, this problem actually allows us to round, but just for good practice, I'm going to continue and write this in simplest radical form. And these types of problems can be kind of difficult just because these numbers are pretty big. Okay, so run through your list of divisibility rules. And I know that this is an even number, so it's divisible by 2. But I also know further that I have the last two digits here are 36, and that's divisible by 4. So that means the whole thing is divisible by 4. And I can separate this into the square root of 4 times the square root of 336 divided by 4 is going to be 84. Okay. And that tells me that square root of 4 is 2 times square root of 84. Now, the square root of 84 is actually reducible again. And if you look at this number, 8 is divisible by 4, 4 is divisible by 4. So the whole thing's going to be divisible by 4. So this is going to be 2 times the square root of 4 times the square root of 21. Simplifying a little bit further, I get this 2 times the square root of 21, which is equal to 4 times the square root of 21. Okay. 21, it turns out, is not reducible any further. If you did split it up, you would get 3 and 7, and that's as far as you could go. Okay. So we can stop this right here. Now, so many people stop at this point and they say that this is the final answer, and it's not, because remember, we are looking for the area. We are not looking for simply x. So now the last step that remains is we have to take this and substitute it back into here. So this is equal to 8.5 times 4 times the square root of 21. Okay. So the square root of 21 I'm going to leave alone. 8.5 times 4 is 34, square root of 21. And once again, we are allowed to round, so if you want to type this into a calculator and figure it out, that's acceptable in this problem. Since I have the exact answer, I'm going to leave it as is, and this is feet squared, or square feet, since those are my my units. Okay. I think if you did type this into a calculator, it comes out to like 155.8. So both of these are acceptable. But the point I want to make here is, one, draw a picture. Two, remember what you're calculating. And three, make sure that you actually answer the question. Okay, so many of my students do a great job of solving the problem. They just don't actually answer the question that's asked. Well, there you have it, another example of a problem that is not too difficult but can be tricky. As always, be careful in your work. Ask for help when you need it. Thank you for watching, and have a wonderful day.